Alright, today I have a 1998 Ford F-150. Check engine lights on. If I go to codes menu, I have the system lean codes 171, 174, and the 1000 is because someone cleared the codes and it's just all the monitors aren't set. So if you go in generically, that 1000 won't even show up. So I'm going to chase the system lean. There's a couple things on the scanner I checked before I even opened the hood, and the first one is actually just the freeze frame data. You want to see under what condition it's setting the lean codes. It captured the code at 1250 RPM, maybe 190 degrees. It caught my fuel trims, the long term's positive 10 and 11. I'm sure it was higher than that, and about 32 miles per hour. So there's two different main issues with the system leans. Either you have a vacuum leak, or there's something wrong with the mass airflow sensor or the ducting in between the mass airflow sensor and the throttle body. When I see codes like freeze frame data like this, I'm not even looking for a vacuum leak, because if it was an intake vacuum leak, like a PCV line or something ruptured, it would be at idle, and I would be at 0 miles per hour or almost 0. So you can confirm that by going to the data display. Just pick one of them that's going to give you fuel trims, and look for your long and short term fuel trims. Right there in percentage, and you can see at idle essentially 0. So there is no issue here. But if I were to, say, put it under a load, raise the RPMs a little bit, you can see my long terms going up to almost 30%, which is maxed out. So it's a higher RPM issue, which is usually, like I said, in the mass airflow sensor or the ducting in between, where it's got unmetered air and it doesn't know what to do with it. Now, another quick thing you can check here, which helps out a lot, and usually when you see this, my baro, the hertz, the frequency, if I go to that, you can see I'm at 129 hertz. Now that correlates to altitude, and the computer uses the mass airflow sensor under moderate load or full throttle to determine baro frequency, which is your altitude, and there's a chart for that. So I'm in Pennsylvania. I'm maybe 1300, anywhere somewhere 800 to 1300 above sea level, and I should be seeing 147 to 156 in that range. So for me to be that low, I'm dealing with an unmetered air or incorrect airflow calculated. I have a chart for that. I found this chart years ago in Mitchell somewhere, and I'm not going to look for it, but I posted it on our window, and it's been there forever. And it goes by altitude above sea level, and I'm, about, like I said, 1300, 1500 max here, so I should be seeing the 155, but like I said, sometimes I'll see 151 and I'll be okay with it, which puts me near the little above 2,000, which I could be in the mountains here in like the Laurel Mountains. So That's what I'm looking for. At 129, wherever I had on the scanner, it shows me at 10,000 feet. So the computer's not going to even try to give me enough fuel, because at 10,000 feet there's not enough oxygen to burn it. So that's where my issue lies. We'll go from there. Here's a quick picture of like a cross-sectional view of a mass airflow sensor, and what you have here is you have your hot wire and your cold wire, and as air rushes across the hot wire, the computer maintains it, I don't know, 300-400 degrees, I can't remember. So depending on what the amplitude it takes to keep it at that constant temperature, it knows how much air is flowing across it. So it's measured by the cold wire sensor, so that's how it determines, you know, how hot the hot wire one is. So you got two sensors inside that usually get packed full of dirt, and they're insulated, so it doesn't see the air coming across, doesn't cool it down enough, so it thinks that there's not as much flow going through. So you usually clean those off with this scenario, and you'll see a dramatic change on your scan data when you drive it. You should see your fuel trims go negative on the short term, while the long term still positive, and then you'll know it's fixed. So I'll take it apart, see if we can get a good picture, clean it off, and give it a shot. Alright, all you guys that messed with these Fords, you know sometimes these stupid clamps can be a bear to work with, and sometimes they just fall right in. So either way, the mass airflow sensor is in that section. There's a pigtail underneath. Just unplug that, and then we'll tear that apart and get to the sensor. If you look at the inside, there's the mass airflow sensor, and the little hole there is where the metered air goes through to measure where the hot wire and cool wire are. And you have a grommet over here, so you peel that back, the grommet back, and you can get to the connector. And then there's marks on the actual insides right there that'll line up, so you have the orientation right when you put it back together. So pretty much you just like kind of force it a little bit, and it snaps out, and then you can reach inside or on the outside with a screwdriver to unplug the connector, and then you can get the unit out. So we'll do that and see if we can get a better picture of it. Okay, now you don't have to go this far to clean it out, because I'm not going to give you a good picture here, but inside that little hole is my two wires. Okay, you can even see the crud on the one right now. It's just packed full of dirt. Those things should be clean. We'll get an after shot, but just for a better shot, you can spray some mass airflow sensor cleaner through that, let it dry, and throw it right back together. I'm just going to take the sensor out just for video purposes with these two little tamper-proof Torx, so we can get a better look at it. It's got an airflow orientation, so let's do that. I'll give you that picture. Alright, see if I can get this good picture of it. With the screws out, the mass airflow sensor just comes out. If I could get a good background here, you could see how dirty all this is. Now if you see the airflow, so the air's going that way, so all the dirt is going to pack across those two sensors. The lower one's your hot wire, and the one in the back is the one measuring the temperature, cold wire. Now if you look at the other side, where there's the airflow's not flowing this way, that's what they should look like clean. You can see the dirt just packed around the upper one. So pretty much get a can of mass airflow sensor cleaner and spray that off. Like I said, you could just do it right through the hole that this goes in and be done a lot quicker than I am. You don't have to tear it totally apart. Just get that dirt off of there, throw it back together, and look at the results. There, after a quick shot of cleaner, it looks the same all the way around, so we should be good to go. Alright, got it all back in. Fought with that clamp. After a couple not so nice words, I opened up an old wound from a video that's still in the editing process. Let's start it up and see what we got. Alright, got it running. Of course, my frequency in the baro is not going to change until I go out and drive it. I'm still sitting here in the shop. But if I go back down to my fuel trims, you can see they're bouncing back and forth a little bit here. So as it equals out, I do have a little bit of short term higher than what I want it to be. But if I put it under load and I get my long-term fuel trims at the 30, you could see my short-term fuel trims going negative immediately. So there is confirmation that what we did just took care of that problem. So I'll go out and drive it and we can watch the baro frequency change, and then other than that we'll call this one fixed. Thanks for watching.